Okay, so the result of the operation will be determined by 4 active low push button switches. Alright, so kamu ada 4 switches active low labeled by SW0, SW1, SW2 and SW3. They are connected to port A pin 0 to pin 3. Okay, so lepas tu apa lagi dia kata? Okay, so satu lagi, the result of the operation will be displayed on 8 common NX LEDs that are connected to port C. Okay, first thing first, what you're going to do is you need to draw your circuit. Okay, lukis dulu your circuit. Okay, we draw the circuit. Alright, so sekarang ni what happen is port C are connected to common NX LED. Okay, so you have a port C sambung kepada common NX. What is common NX? All of the NX.
VCC.
Okay, all of the NX are connected to your VCC. Okay, so kamu lukislah dulu. Okay, you draw your circuits. Okay, so this is your LEDs. You got a resistor there. And all the NX here are connected to VCC, which is a positive terminal. Okay, so positive terminal of your anode will connected to VCC. Okay, next, what are you going to do? Lepas tu nak buat apa pula?
Clear inputs.
Okay, so sekarang ni, what happen is, for this one here, since this is a common NX, okay, so in order to turn on this LED, you need to give 0 or 1?
0.
Okay, give 0 LED on. Give 1 LED off. Okay, next. Lepas tu apa lagi? Alright, lepas tu, okay. Next, selection of operation. Okay, which is addition, subtraction, multiplication and division. Okay, are connected to 4 active low push button switches labeled by SW0, SW1, SW2 and SW3 connected to your PA port A pin 0 to pin 3. Okay, so you have kat sini PA0 sampailah PA3. Okay, all of these switches are connected to active low switch. Okay, so kamu lukislah nanti. Okay, means that every time you press the switch, what happen is it will give 0 to your micro P. Okay, when press, you will get 0. If you release, it will give you 1. Okay, and then sekarang ni what happen is, okay, if you see here, you are going to do arithmetic operation of 2-bit number of A and B. Maksudnya kat sini, okay, so you have 4-bit number, okay, 2 4-bit number, which is starting from A0, A1, A2, A3. Okay, so this is a A for number A, and then you have B3, B2, B1 and B0. Okay, so this is for number B. Okay, so this A and B are coming from switches. Okay, so you have another switches, okay, which is switches. Alright, these switches here are connected to port B. Okay, PB0 to PB3 will represent data for A. Okay, so PB3 to PB0, okay, this is for data A, while for data B coming from PB4 to PB7. Alright, switches from PB4 to PB7. Okay, so satu lagi kamu ada port B. Okay, all of this port B here are connected to switches. Okay, dia tak bagi tahu kat sini active low or active high, depends lah. Okay, you want to draw active low or active high, doesn't matter, tak kisah pun. Okay, so contohlah kat sini kita give a active low jugalah. Alright, so this is 8-bit 8-bit of active low LED switches are connected to port B. Di mana this one here, okay, used, okay, to give you this number, okay, number A and number B, which is, kalau you see here, PB0, PB3, okay, indicates that the number represent for A, while switches from PB4 to PB7 represent the data from for number B. Okay, sampai sini semua clear? Any question up until here? Ada soalan tak sampai sini? Any question? Semua clear? Alright, great. Okay, so sekarang ni, okay, so this switch ya, yang switch kosong, switch 1, switch 2, switch 3, okay, which is connected to PA0 to PA3 kat sini. Okay, if you press this switch, what happen is you do this operation. Okay, you select this operation here. You have 4 switch to select your operation, and then another 8 switch to represent your numbers. Okay, the numbers that you want to do the arithmetics lah. Okay, the arithmetics operations. Okay, so you're going to write a program in C language for part A till part F to fulfill the system requirement. You can use built-in delay. Okay, dibagi tahu kat situ, guna built-in delay function provided by C. Okay, choose 1 second delay and clock frequency is 1 MHz. Okay, given that external sama dengan 1 MHz, and then you need to create a delay of 1 second. Okay, how to do that? Macam mana nak buat? Okay, first dia dah bagi kat situ guideline. Okay, it give you the guideline. Define the directive and declare the headers. Declare the function prototype. Declare the input variable. And then dia ada missing tak kat D ni? I think macam ada missing. Is it ada missing kat D ni? Okay, saya tengok semula soalan. What is D? Okay, write a C program to swap data. Okay, so kat D tu ada satu lagi missing ya. Sekejap. Okay, salah. D is not D. Okay, write a C code from swap data, and then write a C code for addition and do multiplication, and write the code for main program, including the portion initialization, switches press, detecting tasks, and other necessary code. Okay, so we follow this guideline here. Okay, first A, define the directive and declare the header file. Okay, apa yang kita nak tulis kat situ? For A. Okay, so we include, okay, so we define the directive dulu. Okay, first you, okay, sorry, pakai ni pula. Okay, saya pakai ni. Sekejap. Okay, I move this one ya, supaya dia pergi kat bawah. Okay, we start with okay, hashtag include, okay, avr/io.h. Okay, this is the first derivative that you need to include. Okay, lepas tu, what else? Apa lagi kita kena letak? Interrupt. Amir says that you need to include the interrupt directive. No need to include the interrupt directive. Kenapa kita tak guna interrupt? Okay, we don't use interrupt in this program. Kita tak pakai pun interrupt kat program ni. Alright. Next. Apa lagi kita kena include? Okay, you need to include the, mana tadi ya? Okay, saya kecilkan sikit kat sini. Okay, I put here. Okay. This one I put here. Okay, ni. Mana tadi? Okay, this one here. You are going to use the built-in delay function provided by C. So you need to include what header here? Okay, util /delay dot hash. Okay, so you need to include this file here, util /delay dot hash. Kenapa? Because we are going to use the delay function provided by C. Okay, satu lagi what you going to do to include? Satu lagi, apa lagi kita include? Okay, your external punya frequency. Okay, so define f underscore CPU 1 megahertz. Okay, so that is for A lah. Yang ni untuk A. Okay, next you are going to declare the function prototype. Okay, A kita dah done, and then B, declare the function prototype. How to declare the function prototype? What is the function prototype? Siapa boleh bantu? What is the function prototype in this case here? Okay, you see kat sini, kat table ni. Okay, this is your function prototype that you need to declare because you going to do a subroutine kat sini. So you need to declare dulu you punya function prototype. Okay, macam mana nak declare? How to declare your function prototype? Okay, by typing void. Okay, make sure that the function name are same with this table here. Okay, void do addition and then void. Okay, tu satu. You have 4 function prototype here. Okay, satu lagi void do subtraction. Okay, and then void do multiplication. And satu lagi is void do division. Okay. Next. Okay, we've done this part. Okay, B dah siap. Okay, kenapa dia pergi kat situ? Okay, I erase this one. Okay, lepas tu. Next. Declare your input variable. How to declare your input variable? What is your input variable? Okay, in this case here, what is your input variable? This lah, your data A. Not that one. That one is input output. IO variable, IO input output port. This one is input variable. Okay, your input variable is your data. Okay, the number that you want to key into your micro P. Okay, this A and B. Okay, kita declare dulu kita punya input variable. This is your input variable. So you can put this one here. Okay, tulis je lah. Okay, this one here, this is an unsigned character. Okay, so we just type unsigned char. Okay, A kita panggil dia. Okay, A we name it as a data A. Okay, so okay, and then another unsigned char data B. Okay, actually this one here you can initialize, okay, or you can declare this input variable in your main programming. Okay, nak letak kat main programming pun boleh, nak letak kat luar ni pun boleh. Either way also can, as long as nanti whenever you going to get your data A and data B, make sure that you use the same name lah. Okay, lepas tu, okay, C kita dah siap. Okay, so you are going to write a C code for swap data function to read data from switches and generate A and B numbers in the separate variables. Okay, kenapa kena buat tu? Why we need to do this function here, swap data? Kenapa? Anyone want to help? Kenapa we need to do the swap data? Okay, because your data A and data B are coming from which switch? Port B kan? Switches that are connected to your port B. Okay, let's say this is your port B. Okay, so this is port B. Okay, so this is from 0 to 3. Okay, from bit 0 to bit 3 are okay are dedicated to numbers A, and while bit 4 and to bit 7 is dedicated to numbers B. Okay, so you need to separate this data here. Okay, so that A will have 4-bit data, while B also will have a 4-bit data. Okay, so that's why we're going to do another function here called a swap data. Okay, macam mana nak buat swap data punya function ni? Okay, you just put void swap data. Okay, void. Okay, so open curly bracket and close curly bracket. Okay, the question is what is the programming that you're going to write inside of this function swap data here? Okay, so kat sini kita tambah satu lagi. Okay, we need to add another one here. So this is for swap data punya function prototypes. Okay, so void swap data void. Okay, first line dia, what we going to do? Apa kita nak buat ni? Dekat first line ni. For the swap data. Addition, no. We cannot use the addition. Tak boleh lagi. Don't do the addition because addition, you have another function for addition. Okay, another subroutine for addition. This one for the swap data punya subroutine. Okay, what you going to write inside here? Okay, swap data is equal to pin B. Okay, so we'll write, jangan letaklah swap data equal to pin B. We just put pin A. Oh, sorry. Not pin A. Data A. Mana saya punya eraser? Okay, this is my eraser. Okay, so betul tak saya punya ni? Okay, salah. Okay, so data. Okay, make sure that this is a small d. That data A equal to pin B. What happened kat sini? What happened here? Okay, all the value from port B, which is you read by you using the register B, will go to data A. But for the data A, okay, you only want to have the value from bit 0 to bit 3 only. Betul tak? Okay, what about this data here? Apa yang berlaku kat sini? Okay, contohlah. Okay, you have a contoh here. Okay, let's this is the value that coming from your port B. Okay, contohlah kat sini. Sini 1011. This one is 0010. Okay, if you write something like this, what happen is data A. Okay. Okay, sama dengan this value 0B10110010, which is wrong lah. Okay, why wrong? Because data A is a 4-bit data. Okay, which is the data that only consists coming from bit 0 to bit 3, which is this. Okay, data A supposed to be 0010. So how to get rid of this number here? Macam mana kita nak buang this number? What you going to do? Because if you write down here, data A equal to pin B, okay, this is the value that going to your data A, variable data A. But now, your data A is supposed to have this number only, 0010. Okay, 1011 is belong to your data B. So, macam mana nak buat? How to do that? What are you going to do? Okay, so data A equal to data A, okay, do logical AND with what number here? 0x, 0f. Okay, so what happen here? If you do a logical AND, okay, so this is your data A. Okay, you do logical AND with 0, 0, 0, 0, 1, 1, 1, 1. What happened? Okay, you will get this 0, 0, 0. This is 0, 0, 1, 0. Okay, so you get this value. Okay, while this value kamu dah buang. Okay. Okay, so what happened here? After you write down this, what we call here, this line here, so data A will have what value here? Akan dapat value daripada PB0 to PB3. Okay, next, what about data B? What we going to do for the data B? Okay, data B. Macam mana nak dapatkan value data B, which is this value here, 1011. How to do that? Okay, so data B equal to pin B, okay, which is correct. And then after that, what are you going to do? Okay, if you put data B equal to pin B, so the same thing happen lah. Okay, data B sama dengan 0B 10110010. But now, data B should only have this number here. So you need to get rid of this number. Okay, because this one belong to data A. So how to do that? Okay, so data B, okay, and then data B end with 0x f0. Okay, so you end with this number here. What happen is kamu akan dapat, okay, so you end with this number 11110000, and then you get 10110000. But okay, if you left data B, okay, like this, what happen is this is 8-bit data, not 4-bit. Okay, your data B should be a 4-bit data, which is consist of 1011 only. So what you going to do? Kalau kamu tinggalkan macam ni, kamu dapat 8-bit, which is the value of data B is 10110000, which is wrong lah. So what you going to do? Swap. How to do swap? This is a C programming. Kalau assembly language, we can do swap position. But this is C programming. How to do that? We doesn't have a swap instruction for C programming. Invert. You cannot invert. If you invert, what happen is if you do the invert, okay, dia akan dapat, okay, let's say lah this data B here. Okay, you do the invert kat sini. Okay, you do the inversion. Dia akan jadi 01001111, which is wrong also. Macam mana nak buat? How to do that? Okay, why not? We shift this number here to the right by 4 times. Boleh tak? Can we shift this number to the right 4 times? 4 kali. Okay. So, contohlah this is your number here. 1011 0000. Okay, you shift it 4 times. 1, 2, 3, 4. So, this is become 1. Okay, this one also you shift 4 times. Dia akan jadi 1 kat situ. This one also dia akan follow lah. 1. And this one here will kosong. Alright, so you get the 1011. Okay, so we do the shifting. Okay, shift it to the right 4 times. So, macam mana nak buat? You put data B sama dengan, okay, data B, okay, shift to the right. How many times? 4 times. Okay, so you get data B equal to this number here. Okay, 1011. Okay, so we finish the swap data. Okay, next, write a C code for do addition and do multiplication function. Okay, so we're going to do the do addition and do multiplication function. Okay, so how to write a code for do addition. Kita buat do addition dulu. Okay, we do the do addition first. Okay, how to do that? Macam mana nak buat? How to write the code for do addition? Okay, first, you're going to do the subroutine lah. The do addition subroutine. Okay, void do addition. Make sure that the name is sama. Okay, void open clear bracket and close clear bracket down here. Okay, so what you going to write down inside of this do addition subroutine? Nak tulis apa ni? Dalam ni. What you going to do? Okay, kamu nak tambah. Okay, do addition. Okay, addition equal to data A sama dengan data B. Okay, so this do addition ya. Okay, the result of do addition, kamu akan send out to which port? Port C kan? All the result here will be send it out to your LED kat sini. Betul ke tak? Yes, you going to send out, okay, every time you do the addition, subtraction, multiplication, division, the result here will be sending out to your port C and it will be displayed on this LEDs, common and net LED. Okay, so apa yang kamu kena buat? Okay, first, what you're going to do is, okay, port C sama dengan, okay, data A, make sure the name is same, okay, with the above, data B. Okay, betul ke macam ni? Is it correct? Itu saja. What else that we're going to write down inside of this do addition subroutine? Apa lagi? What else that you're going to write down inside of here? Okay, send as an output. Okay, you already send it as an output because you see here port C sama dengan data A plus data B. So this one you already send out to your port C. Okay, before you send out this data here to the port C, what you going to do? Okay, you need to call lah your swap data subroutine. Okay, after you call this swap data subroutine, what happen is, okay, all the data A and data B, okay, so the data A, data B that you read out from pin B, okay, we have a 4-bit number. Okay, that's why we do here, because we want to segregate, okay, the value that we read from pin B to data A and data B. Okay, so that's why here we need to call out the swap data instruction function, and after you call the swap data instruction function, so you already have the data A and data B value. Okay, once you have the data A, data B value, so you put lah to, okay, do the addition data A plus data B and send out to port C. Okay, betul tak? Okay, but in this case here, you using a common NAND. Okay, what is a common NAND do? All the VCC are connected to your positive terminal. Okay, to turn your LED, you need to send 0. Okay, but in this case here, what you going to do? Okay, contohlah kat sini ya. We have this number here. Okay, so mana tadi? This is the data B kita. Kita punya pin B. Okay, the value that coming from our switches. Okay, dekat pin B 1011 and then 0010. So this guys here, okay, yang ni belong to data A and this one belong to B. Okay, so you do the addition 1011 plus with 0010, you will get 0. Sorry, this is 1 0 1 1. Okay, so if you send out this value here, what happen is, okay, this guy here will turn on while this 3 here, okay, this value here will turn off. So what are you going to do? Okay, you need to do the inversion. Okay, so you just put invert dekat sini. Okay, invert kurungan. Okay, put the bracket data A plus data B and send out the result to your port C. And then ada lagi tak yang kita tinggal kat sini? Okay, you need to call a delay lah, because dekat atas ni, okay, kat atas ni you see here atas ni, okay, choose a 1 second delay. Okay, every time you send out this the result, so you just put a delay of 1 second. Okay, dekat sini. Okay, macam mana nak create a delay of 1 second? By using the delay function lah, delay underscore ms. Okay, so what is the value that you're going to put here inside of this bracket here? 1 second. What is 1 second? 1 second delay. So what is the value that you're going to put here inside of this bracket? The delay underscore ms bracket. Okay, 1000. Okay, you put 1000. Okay, any question? Sampai sini ada soalan tak? Up until here. Mana saya punya eraser ni? Tak keluar. Any question? Up until here? Kat sini? Okay, no question. Then next we go to, okay, kena buat satu lagi, do multiplication. Okay, samalah. Similar to do addition. Okay, you create the do multiplication function or subroutine. Void do multiplication. Okay, make sure that the name is correct, sama dengan yang dalam table. Okay, open curly bracket and close curly bracket. Okay, first what you're going to do is, okay, call a swap data function, because you're going to get the value A and B. Okay, from pin B. Okay, panggil dulu swap data. Okay, once you get the call the swap data subroutine, okay, you already get the data A and data B values. And then after that, what are you going to do? Okay, just do a multiplication lah. Okay, port C. Okay, send the multiplication result to your port C sama dengan data A. Okay, what is the symbol for multiplication? Okay, star. Okay, you put a star here and data B. Okay, again, you need to put the tilde here. Okay, so that because because here you're using a common and that. Okay, so you need to make sure that you put the tilde. Okay, after that, call a delay. 1,000. Okay, so you have do addition, do multiplication. Okay, and then you can do another subroutine for do division and do subtraction. Semua sama. Okay. Okay. Next. Okay. Lepas tu last here. Okay. So write a C code for main function including port initialization, switches press, detecting the task, and other necessary C code. Okay. So now we are going to do the main programming. So int main void. Okay, open curly bracket. So what you going to write here? Dekat under int main void. Apa nak kena tulis dulu? What you going to do? Inside of your main program. Okay, so this is your main program. This one here, this is your subroutine. Okay, for do multiplication, swap data, do addition, do division, etc. Okay, so you need to declare your input output port. How to declare your input output port? Okay, so LED connected to port C. So DDRC equal to 0xFF. Okay, port C sama dengan output. Okay, what else? What about your switches? Okay, DDRB equal to what value? 0, because port B you connected to your switch. Alright, so you need to make sure that your port B sama dengan input port. Okay, port B sama dengan input. Lepas tu, after you make your port P as a input, what you going to do? Okay, enable pull up resistor. Okay, next. Apa lagi? Okay, DDRA equal to 0 as well, because this is another, what we call here, another switches that are connected to your port A, which is 4 switch daripada PA0 to PA3. Okay, why not we just put 0? Okay, make all the port A as a input. Okay, so port A sama dengan 0xFS to enable your pull up resistor. Okay, next. What are you going to do? Okay, sekarang kita nak read the switch. Okay, we going to read the switch. Okay, let's say lah we create a variable. Okay, one variable to read a switch. Okay, let's say lah kat sini I put as a DW switch ataupun read switch Okay, salah. Sekejap, this is wrong. Okay, read SW. Okay, so what is the data type that I need to put for my read SW variable here? So I just put the volatile, okay, UINT 8 _ read SW data. So I make my read SW sebagai apa ni? unsigned integer. Okay, so continue kat sebelah ya. Okay, so I continue here. Okay, so I want to what we call here read the switch continuously, okay, forever or continuously. So I put inside of my while loop, while one. Okay, so open curly bracket here and close curly bracket down there. Lepas tu, what I'm going to do? Okay, tadi kan kita dah declare our read switch. Okay, so I just put read switch equal to, okay, from what port that I want to read my switches here. Which port? Is it port A, port B, port C, or port D? Okay, this switch here is used for to to determine the arithmetic that are you going to choose here, either multiplication, division, addition, and etc. Okay, so to port A. Okay, so read SW with pin, yeah, because port A is an input, so we read from the pin A. Okay, so sekarang ni this is your Atmega lah. Okay, so PA0 sampai PA3 you connected to switch. But the question is PA4 and PA5 and 7 you are not connected to any switch. Betul tak? If you not connected to any switch, what happen to this switch here? Dia akan always zero, which is kita tak nak lah. Because why? Because this is an active low. Okay, whenever you press, it will give zero to your micro P. Okay, but this one here not connected to any switch, so the micro P will assume that this value also zero. So we don't want to do that, so we do a masking. Okay, so we do a masking so that PA4 to PA7 always 1 1. Okay, so this is your pin A punya register. Okay, 0 1 2 3. Okay, this is depend on your switch. Okay, so I put don't care lah. If you press, it give 0. If you release, it give 1. But for this one here, bit 4, 5, 6 and 7, you are not connected to any switches dekat sini. So it always produce 0. So I don't want to produce a 0 because I use this active low switch. Okay, whenever you press, it will give 0. So I don't want this value here always 0. So I need to mask it so that it become 1. So how to do that? Okay, so that's why read switch equal to pin A or with 0x F0. So dekat sini nanti, this value here will always 1. Okay, while bit 3 and 2, 1 and 0, the value is determined by your switches that you connect here. Either you press or not. Okay, so this one yang kita panggil dia sebagai masking. Okay, so once we already did the masking, next what we are going to do? Okay, we use the if else statement lah. If read switch equal to equal, okay, contohlah sekarang ni for switch 0. Okay, if switch 0 is pressed, what is the value that you want to what we call here to compare? What is the value for the switch 0? 0B. Anyone can help? If the switch 0 is pressed, what is the value that you want to compare here? 0B. Come on. What is the value that you want to compare? If you press only switch 0. Okay, you press switch 0. What happen here? Kat sini akan jadi kosong, betul tak? What happen to bit 1? Produce 1 lah. This one also 1, 1, and this one also always 1. So we compare with 0B 1 1 1 1 1 1 1 0. Okay. Okay, so this is when the switch 0 is pressed. Okay, bila mana switch 0 kamu tekan. Okay, if the switch 0 is pressed, what is the arithmetic that you're going to do? Okay, do addition. Okay, just put this inside here. Okay, open curly bracket, do addition. Okay, call your addition subroutine. Okay, and close curly bracket. Okay, else if. Okay, the next switch that we're going to press. Okay, what is the next switch? Okay, let's say lah sekarang ni switch 1 you press. What is the value? Okay, so switch 1 is pressed. So read SW with, is it equal to 0B 1 1 1 1 1 1 0 1? Okay, this is switch kosong switch kosong, and this is a switch 1. If yes, what happen? What are you going to do? If yes, do subtraction. Okay, so do subtraction. Okay, so this one here, okay, you need to refer to this table lah. Make sure that you refer to this table here. Nampak ni, table kat atas ni. Alah, lag pula. Okay, switch 0, addition, switch 1, subtraction, switch 2, multiplication, while switch 3 for division. Okay, so now we're going to do the subtraction. Okay, mana saya punya ni? Okay, and then close. Else if, tambah lagi, else if. Okay, now we are going to read when you press switch 2. Okay, so read SW equal 0B1 1 1 1. Okay, what is the switch 2 value? 1 0 1 1. Okay, so this is when switch 2 is pressed. Okay, apa yang kamu kena buat kat sini? Do multiplication. Okay, so call the multiplication subroutine. Okay, and then else if, okay, read switch sama dengan, okay, when switch 3 is pressed, 0B 1 1 1 1 0 1 1 1. Okay, so this is a switch 3. Okay, what happened? Okay, you call do division. Huruf besar ke division ni? Okay, make sure the name is same to your subroutine. Okay, to the table. And else, okay, if you do not press any switch, or what happen is do nothing lah, tak buat apa-apa. Okay, so do not return everything and close the curly bracket. Okay, this is for the while loop, and then this is for the main program. Okay, any question? Ada soalan tak? I think we need to stop here lah. Dah sejam lebih lah. Ada soalan? For question 1. Okay, this one I use the if-else statement lah. Okay, you can use the case statement. Okay, so the case statement we already did in the previous exercise. Okay, you can refer to the previous exercise by using the case statement. This one I use the if-else statement. Okay, another solution is we can use the case statement. Okay, ada soalan tak before we stop here? Okay, question 2 kita akan continue next week ataupun maybe lah we do another extra class ke, who knows, if you want. Okay, kalau kamu nak, I can give you another extra class, okay, for this question 2 here. Okay, we have a lot of previous example to discuss. Okay, ada soalan tak? Okay, if no question, then I think we stop here. Alright. Okay, thank you, class. Okay, make sure that you sign the attendance. Okay, for those who's just come in, okay, who not yet to sign the attendance, please sign the attendance. Okay, I already share in the chat box. Okay, kat sini dah nak hujan dah kat sini. Okay, dah gelap dah. Okay, so thank you, class. Okay, and see you next time.